long time ago, and it's still working, but the design is old. When you compare it, for example, to Y7 Echo Fox designs in ASNEC, it's a big difference in diagram and a big difference in gain, and also the SWR curve and everything. Sorry? Yeah, chef, yeah. Then OB13, this is like a third direction antenna. Then we have some beverages back in the woods. These woods behind are not, this is direction North America. This is north here. Here is S58 Alpha, Boris location. He's a bit higher than we are, so, but what can you do? Then you have this need to connect 5 transceivers, all the amplifiers, all the bandpass filters, all the receiving switches. So what were the requirements before we wanted to go into doing anything? The first one I mentioned a little bit, never touch another cable. We don't want to do anything. Just come to the station, turn on, and work. It has to be ready for this 2 times single up single band. It has to be ready for single up 2 radio, multi-single and multi-2. So inherited in the design, you will see this later, is that you can transmit maximum on 2 bands. You cannot do 3rd band. Then you would have to touch a cable, and we don't want to do this. Every operating desk should reach everything, so it's not important whether you sit on the left side, right side, or at home, or working remote. You have to reach everything, all the rotators, all the amplifiers, everything. The only limit here is the Microham MK2R Plus for the SO2R. You have to be there at the stations where this is, because we really like this unit. Where is Joseph? Here. And I'm afraid when it will broke, I don't know what I'm going to do then. This is the only limit actually that the equipment poses to you. Then to reuse everything what we have. So all the switches, all the amplifiers, we have many bandpass filters from 4 Oscar 3 Alpha. We have also your amplifiers, Ranco, and all the old amplifiers, the tube ones, and everything what we picked up in this since year 48 has to be reused, because we will not throw anything away. And of course, we don't have unlimited money. Then to be strong, to keep the rate, so we are not sleepy, right? So 2 directions, 2 amplifiers to 2 directions. This was also a requirement. Everything remote, maximum do it yourself. So let's learn in the process, let's develop something, and let's have fun. And to join, to be one of the cool kids, right? It's always better to be in the cool kids group than with the losers. So if I paraphrase the Delta 4 motto, make the station stronger than the operator. This is the goal. So it's, if the operator is average, then it's not so difficult. Yeah. This guy, he's a professional climber from Himalaya, and he had to tighten 1 bolt here. We forgot to glue the bolt, and he went up and tight. And the funny thing is, it was the wind was around 60 kilometers per hour, 15 degrees. For me, this is non-climbing climate. I don't know. I don't go up there. And he said, in Himalaya, this is quite good weather. I will go up. So he went up there, and he was so happy. He shared the photos with all his friends on his social network, everything. So it was a nice experience. And I think we paid 120 euros for that service. It was crazy. Yeah, that's dale. Yeah, sorry, Bratzo, to lower your prices. Sorry. Yeah. So what was the solution? Andrei will tell you more about it. Yeah, big mess, as you can see.
So you saw the requirements, so we dwelt on the schematic for quite a long time. So we drew the schematic in Dravio. It's an open source program for drawing diagrams. So we drew and every time we draw something, another box, another 8 time to appear on it. So this is the current schematic of the system. So these are the transceivers. So there are 6 places, and this is for the, we are in the some 9 alpha youth program or some youth program, and there's another flex radio that's connected. So, but we aimed for 6 seats. Currently only 5 seats are at the station, and also the VNA is actor here in the game. So, so the realization was quite late. The realization came that we don't. Every time you put like 6 antennas into 1 to 6 switch, if you actually cut off 5 antennas because you can only select one. So the realization came quite late that we have to, right behind the bandpass filters and stuff, we have to have the switches that switch between RX and takes, how to say, the side of the schematic. So everything that is not used for takes can be used for receiving. So RX takes switches. These are the switches we made with a quite good isolation, around 100 decibels. So we put everything what is transmittable, receivable, everything on a switch. So this is the receiving side. You see here then the stack matches, the 6 to 4 switches, and then some more switches, and they go into the RX ports of the transceivers. So we have here the 890 and 890 and 590 Kenwoods. So these go to the RX ports of those transceivers. You see on the schematic here is the great. We make this is the receiver, the gray side. We made the receiver RX takes switch inside the transceiver itself. We modeled. So you see this switch inside. This is actually inside the Kenwood. So one okay. Yeah, so this is what I'm trying to say, that we modeled the transceiver, you know, with this RX takes switch inside. So one is RX and one is takes. You can see. Okay, next, please. Yes.
How do you share the RX side to you have numbers of antennas?
Yeah, these are the 6 to 4 are the fan out 2 times. Yes. So the one of the 3 antennas is chosen here can be one. This is the stack match, so it can be 1, 2, or 3. Yeah, but here is 4 of them can listen to any of the 6. So you know 4 of them can listen to single disc. So yes, yeah. So this is primary and this is secondary. These are connected directly, but these and these are little how to say, unprivileged a little bit because of 6 to 4 is designed like this.
And
yeah.
They can listen to the inbound antenna which is going through the other 6 to 4 switch.
Yeah, but they can listen here. This is the receiving group antenna, so there are no RX-TX switches. These are connected again. Any of them can, no, any of them, but they can listen to.
Okay.
Like there are some limitations because of. Okay. Yes. Yeah, sure, because the receiving is this part, and no, if you go next. So this was, before idea was to receive here, so any of them can receive any, and but takes every, the requirement was that every transmitter can reach any of the amplifiers and any of the antennas. So yes, it's possible to, any combination I think goes, because actually it can do 3 directions because of the stack matches here. So these spread out, and then you can do, like, if you could do 3 directions if you want with the 3 amplifiers, any 3 directions with any, well, a little bit of the how to say, this linear and this linear are like reserved and primary. You see, so one if somebody goes here, this is the these and these are special linears reserved for the here from the design we can see this is actually, you know, you see 6 AB switches and 2 1 to 6 switches. This is actually how to say 2 times 6 switch, but separated. Yeah, it's 2 times 6, and actually the limitation, as Simon said, it's you can only ever transmit, you know, here and here. It's not possible to transmit. Its design itself now prevents the transmission of the third signal. Yeah. So but then we add in like say software we added the limitation that this and this cannot pass the same band, cannot be passed. You know, so it's not possible for 2 stations to transmit on a same band at the same time. But it's possible. We have here, so it has to be we say band exclusive. So this and this band has to be different, and one can transmit here and one here, and it's okay. So it's for it's not multi station. It's for everything multi-2, multi-single, and so on. At maximum 2 signals, transmitting signals can be carried over. Yeah. So you know, like the national play. So this is the schematic. We dwelt really long time on the schematic. Really, I know 2 years to draw. But at the same time we. Yeah. Okay, let me explain it. This is the suite. These the linears, amplifiers. It's sorry, it's amplifiers. Yeah, it's like we every amplifier we put there. So, but usually, you know, like two box before it's attenuator. Yeah, so it's attenuator switches again. Yeah, okay, but it's a matrix input, matrix output. But yeah, this is like a large number of amplifiers, but usually half of them are on repair or something's wrong with them. So it's usually in a service, half of them. The nice thing, for example, this one here, we have this box here. This is actually not an amplifier, it's a combiner. So we present a combiner as another amplifier in the system. So when you choose this path actually cuts out this amplifier and this amplifier, because it uses them both. It's a combiner. Yeah, yeah. Pile breaker again, yes. So this actually, if you use this amplifier, you cannot use this one and this one, because they combine. They are used as in a combiner mode. So this is actually, like I said, virtual amplifier. Yeah, combiner. Okay, we'll never finish. So these were the requirements of the S53M project, and but what else is here? Yeah, it's heterogeneous system. So every switch, every amplifier, this is everything different. So it's not from the same vendor. It has to work with all of the stuff. It has to be really easy to use during contests, because when the contesters are tired and so on, it cannot be like a nuance to deal with, like I brought this system, now somebody has to deal with the system. It has to be really hassle-free during contest, and also maintenance has to be hassle-free. So no not too much to do, during before contest, after contest, and so on. It's a complex system. You saw the requirements, how it should be, resulted in a very complex system. So we have to have some real-time visualization. What is happening? Even if you're remote, what is happening? Which path is used? What linear amplifier is used, and so on. Aim from declarative approach. This is something I think I come up with when the user wants to use some amplifier or some antenna. He merely expresses a wish. It's not a command to the system. So I want to listen to this antenna. Yes, you will listen to this antenna if it's possible. If it's not possible, you'll get some other antenna. Yeah. So this is what I mean by declarative approach. So user merely expresses a wish. So he wants to use 3 antennas, transmit to 3 directions. Yes, but if it's possible, if somebody else is not using, if antenna is available, and so on. And build of the last one is, no, the last one is the build a future-proof solution. So the last solution you saw the picture, organically grow 10 years. This solution we put in place, it has to be for 10 years. So only grow with us in the next 10 years, we will not change it. So it has to be for 10 years. And because it's a hobby, it's a like third activity for me, not job, not side job, but hobby program. It has to be challenging and fun. So this is something. What we came up with, it's the architecture like this. Yeah. So you have the operator control interface. So this is a desktop application. It runs on a Mac, Windows, Linux. It's a cross-platform. It's actually a web view. It's what you see, the receiving antennas, transmitting antennas, some status, and where those antennas are directed. All at one of the requirement. I remember the Drago S59 Alpha said, it has to have all the antennas at site. So everything there is, I want to see what I'm using, where it's directed. So this is the view. So here we see the selected antenna. We'll see in demo next. Okay. So this is the user interface where here magic starts. Operator expressing a wish. He says, I want to see this. Yeah. This communicates to the core. Core finds the best way to interpret the operator's wishes, finds a path in the system from the station, from the operator to the antenna. Yeah? It knows the system through a user-generated abstract diagram. We saw this a schematic we saw earlier. It's actually input to the system. So it's that schematic itself is used to find paths to to achieve, thank you, to achieve the wishes of the operator. Yeah, this core maintains the high-level state of the system. So on the schematic, you can disable some device. You can say this linear is not. It's not. I don't want, or if it's broken, exclude it from the calculation of the path. So this is like you exclude, you disable the device in the schematic. That doesn't mean it's disabled on the rack where you have linears. It's just you exclude it from the calculation of the paths. So this means the high level state. Yeah, and this is implementation independent. So you draw a schematic, you load a schematic. The system is already able to find paths from the transceivers to the antennas. Then, when he finds a path, he says to the driver, let's do this. We have this path in the schematic, let's do this. And the driver itself has some sub-drivers configuration for each device, communicates with GPOs, Ethernet, every heterogeneous, everything, like it communicates with the transceivers, communicates with the amplifiers and so on, to implement the decision that has been made. Like paths are this, like the core says switch should be switched like this or like this, and the driver itself then communicates to GPOs, Ethernet, whatever he does to implement the wish of the core. So when driver succeeds, reports back to the core, it has been done, paths have been established, like you said, everything has been switched, and then core says, okay, now we draw a picture, like paths are like this, you see in a demo, paths are like this, everything is okay, and this is it. So this part is very implementation dependent. So what is in a shack, like here, how do you control this? How do you control this? It's in a driver. So we use currently Node-RED for this. So this is brain. He communicates like to the Node-RED what has to be done. Node-RED communicates, gathers all the responses, says everything has been done, returns the success, and then it is a new state of the system. Yeah? The switching matrix itself, it's yeah. This is important. It's a well-defined barrier between these two, so we can independently test like how this works and how this works. It's like in a demo we will present. I run this on my computer, and I have some fake driver, some how to say fake. It just says, yeah, everything is okay. You see, because actually on a station in a vantage of the station, it actually does something, but on my computer this doesn't do much. It just checks it's everything okay. Yeah. So this got itself a name and logo because this is actually something that can be used in different setups. Yeah. The matrix, the name of this system is the core and input, also provides high-level runtime manipulation. I said disabling, enabling. Real-time visualization. Diagram editor, you can edit the diagram. It has the MQTT API, and it has the cross-platform control interface. So this is something that's not bound to the solution we have at OneHeadshot. So this is something that's implementation independent. Yeah. Yeah. I don't know if some demo time, because this is very dry. Okay. So this looks like this looks the system. This is now running at how to say. I'm running an instance of the system at my place, so we are connected to the at my home. There's just how I said the driver that says yeah, everything is okay. So when it has to switch something, it has it has been switched. So yes. So no, like for example, this is what is meant like a high-level manipulation. You see this is now the primary RTX A1 station, the transceiver, and this I can now say like he's in a mode for 80 because it can be only ever in a single band. So it's in a band 80 or 40. This is the station. This is done through Node-RED. Through API, it is set. The Node-RED communicates with the transceiver and sets this value. So we, at the station, we never set this value by hand. Like it's inactive. You see, it's inactive. This active and inactive, this is done through Node-RED. It communicates with the transceiver. It says, oof, somebody powered up, and through API brings it on and sets its band. Like this is done in a you see I by hand I change the band, but at the station it is done through Node-RED and through communication with the device. Yes. Okay, sorry, too detailed. But this change is reflected then on this control interface, and now you see the 40 because I clicked 40 there. Yes, now it's possible to use some mapped with the keyboard. This we have keyboards like this. It's a €10 keyboard, and the desktop application communicates with the keyboard, and yeah, you can press it. So now even this is like you see, press it now. Yeah, you see the focus is elsewhere. This was very important. The focus is on the logger. You log it, but the keyboard communicates with the you see, and then communicates with the program. And as Simon is, press some more, please. Yeah, it's demo time. Yeah. Yeah. You see now what is happening. This is now like I have a fake driver, but in actuality, this switches everything. You know, you see it says the stack match, switch this, and if you select some transmission antenna, and then you see he's emulating because the enter key is no. Yeah, this is now really remotely connected to my server through SSH, blah blah. But this is what the users see at the when during the contest. You see which linear is used. Like I said, like this is. If you go AutoVX, this is quite dynamic. So we make this inactive, and we make this one active, for example. And now, if he goes to yeah, it will take another path. It will just take another path. So we had in a contest the situations when something was not working, just disable, do some other magic, enable some other linears, amplifiers, go through another amplifier. You see? This was because the system is so complex. You have to have something like this to see what is happening, even remotely. Thank you, Simon. Now, okay, well, what just happened and what has happened now when the Simon was pressing? So first antenna selection. Yeah, he pressed, the desktop showed, but what happened in the system? So the desktop application recognized the change. It set to matrix, another antenna was selected. The paths were recalculated. To the node red it was set switch. Node red said it has been switched, and the desktop application and the web, what we saw, the schematic has been updated, so the visualization. What happens when the what happened when the RX to TX transition, when he did the enter to simulate what has happened? Yeah, what happens in the system? Foot switch is pressed. Foot switch is connected to microhum. Microhum goes out and says power amplifier put at a high. He has an output for you can set 0 delay. It just outputs. Then we read that on some Raspberry Pi configured to just read the pin inputs. It reads high, and it communicates to the node red driver that somebody pressed high and wants to go to the transmission. It says to the core, transmit. It recalculates paths, says back to the node red, come on, do the switches, everything, do the stuff. If it says okay, the target is set, the inhibit is put off. I didn't mention in the next slide I will mention all transceivers are always in the inhibit mode. So when the system says it's okay to go out with the power, then it's inhibit off. If it's unsuccessful, didn't find path, it's not possible, somebody else is using it, inhibit stays on. Yeah, when it goes back, so you release foot switch. I didn't mention the timings. The target was 50 milliseconds. We are now around 60 milliseconds. Everything this happens in 60 milliseconds. But the release of the takes to RX happens in 20 milliseconds. It's you release foot switch, again, microhum says to node red says to the core, let's go to RX, it unsets, recalculates, and so on. So inhibit is very early, is back on. Yeah? Update view and so on. So how is this safe? We try very hard to be safe. All communication is done with confirmation and timeout. So every cat command to the system, it's done in this way: set, read. So we expect everything to read and come back as we said it. So set, read, fashion where response is recognized, expected. It has to be like we want, or else it's error. It's not okay. The driver says I'm unable to fulfill the core's wishes, and it doesn't go on there. All transmitters in inhibit mode by default. So everything, every transceiver that's detected, it's in inhibit at once. Yeah, but when takes RF path is successfully established, the inhibit is turned off. We found a way to visualize this very nicely on a this is, for example, the 590. It has two colors, backlight colors, and we use this to visualize to the operator that when the inhibit is on or off. But he never cares, but he sees if this is the case. Double check. Everything is done double check. The core knows the AB switch cannot go both ways, and driver refuses to execute something that will say go both ways. Like if AB switch gets an instruction to do both ways, this is not possible. So AB switch, the node red complains. Yeah, this is yeah. This is the gist of it. If you have any questions, ask me. We'll have some computer somewhere running with this demo system, so ask me anything. What we, I didn't put a slide on, but what we found out, the current problem or issue is every logger and the whole system of this ham radio automation expects fixed PTT delay. This is not the case here. This and even others, if bring into the system some Ethernet devices or some other devices that are communicating in other ways, the PTT delay cannot be fixed. You see, because the latencies gets unpredictable. Here, like it's 99 cases, it's 60 milliseconds, but 1 in 1,000, it's 150. So we have to have this 150 PTT delay because of that 1 promille chance to lose, dots on the CQ with the CW, and this is something we are now talking to the logger makers like N1MM and others to build into the logger a ready signal. Where the system knows everything has been switched. Now we can go with the the played WAV or the CW message and so on. So these are challenges we are facing now because the system otherwise is working.
Thank you, Andrei. So yeah, it's not over yet. So to loosen up the complicated technical part, I hope it's interesting for you. It's really me and Andrei really struggled how to present this complex system in a manageable way for you. So this is the wall. It's metallic, so to have the common ground, and all the boxes. We really tried hard. Renato, S57UN, is a very neat person. He has this tendency to put the cables in a nice way, but even now it's a mess at the end, maybe like here and here. But you see all the control cables are nice and tidy inside this plastic canals. And we really tried hard to make it nice, but it's impossible. So the feedback, what the president thinks for first, that's me, president of the club. So we reused everything great. We avoided cost and big time, also not so bad. Reactivation of club members, amazing. We like every time something's new happened, then the club is getting more and more alive. This is nice. It's like when you have a new girlfriend or something, then you're also more alive. Contest results, they are not so bad. It's you know very well it's impossible to win anything except if you're Vedran or Brazzo. Then you have to set your own goals, the location goals, the operator goals. We are not, we are not the best operators in the world, but we are good. So contest results are coming, and make the president proud. I'm here today showing this, so I'm proud. Yeah. Yeah, thank you. So this is in Slovenian language, Dogaja, Dogaja. It's happening. Yeah. It's so much fun. Also, you can see Freddy here and Renato. They are very serious, so it means they are listening. System is working. So the user point of view, they massacred my boy, right? We put everything. We really put big trust in Andrei and also in me, our club members, because we dismantled everything, like completely destroyed the station, and started from the scratch. So what the users are saying, ease of use. This was really good feedback from our colleagues. Like, show me this. Drago was very demanding. Renato was very demanding. Show me this. I don't want to. For example, the good thing is when somebody, you are already running and somebody comes to in-band. Somebody presses your band. He has to get the takes antennas that you are using, and he has to get your amplifier, And the station should be set on his transmit power, because when he's going to transmit, he cannot go to some other antenna, he cannot go with the too high power. He has to be ready with your setup. And it's completely dynamic, automatic. We prevent, for example, switching to the wrong antennas to burn the receiver, things like this. Being cool, we are. Yeah, contest results are coming. Developers gives great support. It's the best. And also we added new stuff. About the cables, yeah, still too many, but actually we don't need to touch anything. Just come to the station, select the band. We can put all 6 stations to the same band, or put 2 by 2 by I don't know what, every combination possible. It just happens. You see the dynamic calculations of the pad. So it's great, like Dazdale. And what are the users? We make around 30,000–40,000 QSOs per year, and we ask every QSO partner his satisfaction on the band. We ask them also in CW. So 80% give satisfactory feedback. We are happy to work here, extremely happy. I just like to call them, it feels so good. It's the most frequent response we get on the band. And voted as best antenna by our QSO partners is this 40-meter vertical. It has 3 elevated radials. 100% of wild QSOs are very happy when they work us. 2.7% cluster spots only we get alligatore, no ears, like deaf, things like this. It's good. Last year we had 3%, now we are down to 2.7. And 7.3% females say would again. So it's also not bad. And wife happiness level is still very low, but it's showing positive trend. And if anybody of you is in the business, if trend is positive, everything is okay in the business. So this is part of our team. Maybe even people on this photos, I think they look happy, right? They're working something, but they look satisfied. So not only the users, the people that we make QSOs with, also we are happy. This was the fun side, if you didn't catch it. So where do we go next? Yeah, these kids are looking at the matrix and wondering what the hell is this? Yeah. So to have stacks, we don't have any stacks at the moment. We need decibels to keep the rate, to keep the operator alive. Then the question is who will maintain it? You double the problems, everything. Bratzo is driving often past, so maybe he. Find a good in-band solution. This is actually the biggest problem that we have on the site. No good in-band antenna because of the topology of the hill, because of the neighbors, because of all the issues local. We still need a good solution for in-band. We tried verticals, we tried cranes, everything, but some permanent solution is not there. The best would be, for example, Drago is around 10 kilometers from us, S59 Alpha, just to use his station for in-band over the internet. But unfortunately, you cannot do this. Maybe yours, that would be nice, yeah. Then, yeah, improve all Slovenian records. This is the little goal that we have, and we are doing it. So, you know, to be remembered forever in golden letters in Slovenian history. And since this station is operating, we set all the records. Every time we do a contest, we make a new record. Okay, the conditions are there for us. But also, 13 years ago, also the conditions were good. Always win 9 Alpha contest to have the free boarding here in Porridge. This is also a goal. I succeeded this last year. And yeah, make surrounding terrain adjustments to keep the HF terrain analyzer happy. I told you, Boris's location is higher. There is some hill towards North America that we don't like so much. Oh, well, we are there. We are coming. And yeah, and I was talking about legacy in the start. Try to have fun with this legacy that we have. And really, what was left to us to work with is really, really great stuff. And we are grateful for this. Yeah, I think that's the end, huh? No, okay. This is... Or maybe I can. This ping pong lights is also, this is my development. In the Tango Kilo Zero Charlie activity, we learned that using ping pong balls to signal state of the system is a very good way to keep the sync between the operators. especially in these inbound situations. So we also decided to have a ping pong ball at every station, and this is actually the LED that can show these thousands of colors. So if it's blinking red, or if it's blue, if it's green, red, you learn by using the system, you learn, okay, now the blue light has gone off, so it means the other operator on the inbound is on Eric's, I can transmit. So then you're faster. You look at the light, wait with the switch, and when the light changes color, you go and transmit. So it keeps you in sync with the other guys on the station. Or if there is some major error, for example, like linear amplifier is drawing too much current, then the light will blink red. Do something is wrong. Also on the user interface, it will say amplifier is drawing too much current. Or sometimes we joke, go home, we send messages to each other, go home, the lunch is ready, or something like this. Yeah. Okay, since we started to prepare the presentations, we were really, so we crossed some of the stuff already. So it's in development, but what is important, the system is working. It's not full of bugs, it's not something abstract, working only on the paper. We are using this system in every contest, every time, and I can say with 0 or maybe 1 problem per activity. So it's actually really, really perfect. Okay, I will not go deeper in the. Yeah, so that's the location again. So thank you. I hope it was not too technical or too deep or too long. We are really happy to be able to show you what prepared. Yeah. Okay, about there are 2 schematics on the wall. So whenever you see me or Andrei, just ask us. We can go through that, and there will be a live demo on that counter for the whole day. So you can play with the keyboard. You can try to enable, disable. Yeah, to destroy it. Yeah. So yeah, any questions? And Andy was first. Sorry. I said 1 question. Sorry. Okay. Actually, we pretend that lightning is not existing. All the cables are connected all the times. The filters are first thing that comes after that comes in the shack, and they are all grounded. In the filter you have a coil to the ground. So in 10 years we didn't have 1 problem with the lightning. I don't know why. So we keep it like this. We don't change it. Yeah. So sorry, second question. Yeah. Yeah, you disable it, it gets gray on the diagram, and the system is not using this line anymore. So Andrei was telling, user expresses a wish. I would like to use this antenna. But the system says, no, it's disabled. PAT is not available. You will not get this. So you just click inactive, and then it's out. Yeah. Sorry, I don't, just a little bit quiet, please. Yeah.
This is the idea. Yeah, this is the idea to open source it. But I think maybe I don't know when. But I don't know even if there's a. Okay.
Yeah. Okay. There was some question here. Ti Zimba. How much time?
No.
Oh, fuck.
No.
It was actually the station was offline maybe only for a month. But the preparation period, the drawing, I think we drew with Andrei like 50 diagrams, different ways, and so maybe since the beginning it was 2 years, huh? Something like this.
2, I don't know, maybe
more, maybe 3. Yeah.
But the downtime was like months.
Yeah,
Few
yeah,
months.
yeah.
Few months.
August and September, like this. We were quite good, yeah. Goran?
Do you keep any readable log? And when some user disable it, that the next guest will know what the reason why you disabled it?
No.
No,
No.
not yet, but this is good. Yeah. This is
You,
good. I
you,
was
will
thinking about it.
you will see on the diagram that it's disabled. You don't know why. There is actually a lot of everything happening in the matrix, in the core. We put this in database, but this is something that we haven't done yet. Yeah. No, thank you.
Yeah. Why is something disabled?
Yeah.
This is good. Yeah, I was thinking about that. Or even like temporary disabled, like for 15 minutes disabled, like this stuff like this is interesting. Yeah.
This can be done in
Yeah,
you. Yeah.
like it's in a, like somebody disables something, but sometimes it's in a service. You know, it's disabled for real reason. Yeah. Currently, there's no reason attached to the.
Okay. Any other question, Brazzo?
A statement.
Statement.
The boiler says 5 A would be happy.
Yeah, would be. Yeah.
It is very close to his plate, and I know beginning of his work with his idea to implement such a system without touching cables, and you are all the time connected with him in a very close way. And
Yeah, Boris left us this forward thinking. He was one of the first SO2R operators, and he, you know, in every debate with him was always very demanding with to think, and he left us this direction. It's built in this way. Yeah, it's built in this way. Okay. So yeah, thank you. If you are ever nearby Murska Sobota, you're welcome to see this in live. Thank you.